Hello students, in our previous session we had solved few questions from exercise 2.3. We had solved till the fourth question. In that we had stopped at second. Now we shall continue from the third onwards. In the third and the fourth question we need to find the value of p, and in the fifth question we need to find the value of p as well as q. Let's take up the third question. Look at fourth question. The two equations are having unique solution. Whenever the equation is having a unique solution, again it means that we have a1 by a2 not equal to b1 by b2. For unique solution, again the condition is a1 upon a2 not equal to b1 upon b2. Here a1 by a2 is 2 by p not equal to b1 by b2 is 3 upon minus 6. If 3 and p are multiplied, we get 3p not equal to minus 6 into 2. So p is not equal to minus 6 into 2 divided by 3. We'll be getting p not equal to minus 4. This means that p can be any real value except minus 4. This fifth question is slightly different. We need to find the value of both p and q. Very important thing you should note is the second equation is having the y term present on both left hand side and right hand side. You have to bring that to one particular side and make it as a proper equation. Then you can use the condition for infinitely many solutions. So let me write the given equations. 2x plus 3y equal to 7 is one of the equation, and the other equation is 2px plus py. I'll transpose this qy term which is there in the right hand side to left hand side equal to 28. It is nothing but 2px plus, if y is taken common, you'll be getting p plus q times of y equal to 28. Now we can find the value of a1 by a2. a1 by a2 is 2 upon 2p. b1 by b2 is 3 upon p plus q, and c1 by c2 is 7 upon 28. Here 2 and 2 will get cancelled. You will be getting 1 by p. For infinitely many infinitely many solutions, the condition is a1 by a2 is equal to b1 by b2, which is equal to c1 by c2. Let me substitute. We'll be having 1 by p equal to 3 upon p plus q, which is equal to 7 upon 28. I can simplify and write this as 1 by 4. So let me write this as 1 by 4. Now let me consider 1 by p equal to 1 by 4. This implies p value is 4, and Let me take 3 upon p plus q equal to 1 by 4. On cross multiplication, we'll be getting p plus q equal to 12. So value of q is 12 minus p, which is 12 minus 4, nothing but 8. Therefore, the value of p is 4 and value of q is 8. Let's take up question 5. In the question 5, they are given two pair of equations which are following a straight path. We need to check whether paths cross each other or not. We have to just find out whether we get a intersecting lines or not. We all have learned that intersecting lines will be having the condition a1 by b2 not equal to b1 by b2. To check whether they are intersecting or not, let me consider the given equations. X minus 3y equal to 2, and one more equation is minus 2x plus 6y equal to 5. Let us find out the ratio of the coefficients and the constants. a1 upon a2 is 1 by minus 2, nothing but minus 1 by 2. b1 upon b2 is minus 3 upon 6. Once again we got 1 by 2. c1 upon c2 is 2 by 5. Here we are getting a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. This is a condition, algebraic condition for parallel lines. Since these lines are parallel lines, they do not cross each other. So I can conclude that therefore the paths do not cross each other. Let us move on to the next question. The question is, write a pair of linear equations which has the unique solutions x is equal to minus 1, y is equal to 3. How many such pairs can you write? They are given the value of x as negative 1 and the value of y is positive 3. I can frame the equations or I can form the equations by taking these values of x and y. Suppose if I add them, I'll be getting x plus y equal to, what is 3 added to minus 1? It is positive 2. So this could be one of the equations. I can add the value of x to twice the value of y. So it means minus 1 is added to 6. It becomes 5. So this could be pair of linear equations having unique solution. How can I say that they'll be having unique solution? I can say them because a1 upon a2, in this case it is 1 upon 1, and b1 upon b2, in this case it is 1 by 2. We are having a1 by a2 not equal to b1 by b2. Therefore, they will be having unique solution. So how many such pairs can be made using x is equal to -1 and y is equal to 3? I have taken as x plus 2y. You can take 2x plus y. You can take 3x plus 3y. Sorry, 3x plus 5y. This x coefficient and y coefficient, if you change them, you'll be getting infinite number of ways to make such possibilities, isn't it? Therefore, I can conclude that infinitely many pairs of equations are possible. Let us see the next question. If 2x plus y is equal to 23 and 4x minus y is equal to 19, find the values of 5y minus 2x and y by x minus 2. To find the value of this 5y minus 2x and y by x minus 2, we need to find x and y values. How do we find the x and y values? We'll find it by using these two equations. They have given the pairs of equations as 2x plus y is equal to 23, and one more equation is 4x minus y equal to 19. The best simple way to find out the value of x and y is the elimination method. In this case, if you add them, you'll be getting y term getting cancelled. 6x will be equal to 42, x will be 7. So the value of x is found. Now using this value of x, let me find the value of y. For that, I'll consider the first equation. Consider 2x plus y is equal to 23. Y will be equal to 23 minus 2x. So y will be equal to 23 minus twice of 7. So y is equal to 23 minus 14. You get the value of y as positive 9. Now let me find 5y minus 2x will be equal to 5 times of 9 minus 2 times of 7. So it is 45 minus 14, nothing but 31. We have found the value. One more is given as y by x equal to, y by x minus 2. This becomes 9 upon 7 minus 2. So 9 minus 14 by 7 by taking LCM, you will be getting the result as minus 5 by 7. Let us take question number 8. Find the values of x and y in the following rectangle. See figure 3.2. They have mentioned the sides of the rectangle. We all know that in rectangle, opposite sides are equal. Opposite sides of rectangle are equal. We can make use of this concept. We will be getting two equations, x plus 3y equal to 13, and one more equation is 3x plus y equal to 7. Let me call this as equation 1 and this as equation 2. Now once again I'd like to follow elimination method. What I do is I'll eliminate x term. For that, I will take equation 1 multiplied to 3. I'll be getting 3x plus 9y equal to 39. If second equation is multiplied to 1, you will be getting 3x plus y equal to 7. Let me subtract. While subtracting, I would like to change the sign and add them. X term will get cancelled. You will be getting 8y equal to 32. We know 8 4 times is 32. The value of y is 4. Now we have got the value of y. Let me consider one of the equation. Consider, I would like to take the second equation. 3x plus y is equal to 7. Let us substitute the value. 3x becomes 7 minus 4, which is equal to 3. So if 3x is equal to 3, x value is 1. So we have found the value of x as 1 and the value of y as 4. Let's see the ninth question. Ninth question is having 7 sub-questions. In these 7 sub-questions, let me take up one of the question. Remaining you can try. And the remaining question we shall see in our next session. So let me take the first pair of equations. I'll write it here. In the ninth question, first one is x plus y is equal to 3.3. One more equation given is 0.6 upon 3x minus 2y equal to minus 1. Here we have no problem with this first equation. In the second equation, we need to simplify. Let me cross multiply. I'll be getting 3x minus 2y equal to negative 0.6. Now I will call this as equation 2. Now to follow elimination method, I have to make the coefficients as same. I would like to eliminate y term first. So I multiply equation 1 with 2. We will be getting 2x plus 2y equal to 6.6. In the second equation, we have the coefficient of y as minus 2. So I'll multiply with 1. It simply becomes 3x minus 2y equal to negative 0.6. Let me add them. By adding them, this term, y term, it cancels. We will be getting 5x equal to 6. So the value of x is 6 by 5. Since they have given all the coefficients and all the constants as in decimal, I would like to find the value in decimal. It will be 1.2. Now we have got the value of x. Let me consider the first equation. Consider x plus y is equal to 3.3. So y will be equal to 3.3 minus x. Y will be 3.3 minus the value of x found was 1.2. So y value becomes 2.1. Let me conclude here. Therefore x value is 1.2 and y value is 2.1. simple. We shall take up one more question of ninth question, the second sub question, and the remaining you can try. The second sub question is, the ninth question, second sub question is x by 3 plus y by 4 equal to 4. Whenever fractions are given, it becomes little difficult to find out. So best thing to eliminate this fraction form will be taking LCM and multiplying that. Suppose if you multiply 12 to this equation, it becomes 4x plus 3y equal to 48. Now with this equation, it becomes easy to solve. I'll call this as equation 1. The second equation given is 5 by 6x plus y by 8 equal to 4. LCM of the 6 and 8 is 24. So if I multiply this 24 to this, we'll be getting 20x plus, in the given equation it was minus, so 20x minus 3y equal to 96. Let me call this as equation 2. Now we have got both the equation. Observe the y coefficient is positive 3 in the first equation and negative 3 in the second equation. If I add them, they get cancelled. So I'll write this separately, one below the other, so that you can understand better. 20x minus 3y equal to 96. Now you do addition, add. By adding, this y term get cancelled. 20 added to 4 is 24. X equal to 48 plus 96 is 144. X is 144 upon 24. 24 6 times is 144. Let me consider the first equation, 4x plus 3y equal to 48. So 3y will be equal to 48 minus 4x. So 3y becomes 48 minus 4 times of 6. So y will be 24 upon 3, nothing but 8. So conclusion is x value obtained is 6 and y value obtained is 8. Rest of the question you can try. These questions you can try. And we will discuss in our next session.